In this video, we look at testing Arduino program that uses one of the standard libraries. To demonstrate this, I'm going to be using the LiquidCrystal CI project on GitHub. The organization of this project has two sketches, Hello 1 and Hello 2, and two libraries, Hello LCD and LiquidCrystal CI. I suggest that you download and unzip this project to a temporary location. So we'll say code, download. That will bring us a zip file that we can unzip. I suggest that you copy each of the four folders into the appropriate Arduino directory. With that, we have our top-level Arduino directory. We have the two hellos, and we have the two libraries. In addition, we should install the LiquidCrystal library. So I'm going to go ahead and open up the Arduino IDE, use the Tools menu with the libraries, look for the LiquidCrystal library, select the most recent version, and install it. If we open up and look, we'll see in the Arduino directory Hello 1. Hello 1 is a simple sketch that includes the LiquidCrystal library. It creates a LiquidCrystal object with appropriate initializations, sets the cursor to the beginning, prints out Hello Sketch, then sets the cursor to the second line, line 1, 0 based, and then prints out the number of seconds. So you can see I have my LiquidCrystal display, and I can upload this sketch to the device. And now we see it say Hello Sketch, and it's counting the number of seconds. So that is our first sketch. The second sketch we'll look at takes a different approach. In this sketch, we include the Hello LCD library and then instantiate an object of the Hello LCD library. And then instead of doing things in the setup and loop, we simply call setup and loop for the new object. So what is this object? We have our two sketches, and then we have our libraries. So the Hello LCD library source has a header file that simply defines a class with two public methods. The implementation is quite simple. Again, we include the LiquidCrystal, we instantiate an object, and then the code is very similar. We have a begin, set, and then say hello library, and then update every second the time. So this code is being called from here. So let's go ahead and upload this sketch and its associated things. And now we can see that the LCD says hello library. So we're running this code. That's nice. The challenge is that testing, how are we going to go about testing? The Arduino CI project provides a way of testing low-level bits, pins that have been set, but that isn't as easy for testing something like an LCD display, where it might take a couple hundred digital writes on a pin to get the data that is showing here. So we want to find a different way of testing it. And the goal of testing the library means that we really want to use the LiquidCrystal library, but have a way of testing it. The LiquidCrystal library has a series of methods, constructors, and then things like clear, home, display, blink, scrolling, and then it uses a write or a print and print line to output things to the device. We would like to test to see if we're calling the appropriate functions with the appropriate values. And so what we've done here is we've created a subclass of the LiquidCrystal library called LiquidCrystal CI. And it has the same public API as the LiquidCrystal with some additional testing methods, such as get rows or is blinking, and so on. The actual implementation in most cases calls the superclass. So the constructor calls the superclass constructor. The begin function calls the superclass begin. The clear function calls the superclass clear. The home function calls the superclass home, and so on, with such things as when we set the cursor, we're going to capture the row and column. And when we configure the device for number of columns and rows, we'll capture the number of columns and rows. And then we'll provide accessors, as mentioned earlier, in the header to test and return. So we can come in to our Hello LCD and write a unit test. The unit test will create an instance of the Hello LCD. It will acquire a reference to the LiquidCrystal CI object, and then it will say initially the number of rows should be 1. And then after we run the LCD setup, the number of rows should be 2. And so if we go look at the implementation of setup, setup calls begin with 16.2. And so if the setup code has run properly and did the call to begin that it should, then there should be 2 rows instead of 1. Now, to demonstrate that the tests are actually running independent of the board, we'll unplug the board, and then in the Hello LCD directory, we'll run the test and build. The test and build script ensures that the appropriate gems are present. It makes sure the appropriate libraries and compiler are present to actually run the code locally. And then it uses the Arduino IDE to actually build the various components and test to see that they compile correctly for the device. So here we see that we have the appropriate libraries. We're using these. We've run 3 tests or subtests of checking that there's a reference to the LCD object, that when we start up, the number of rows is 1, and that after running the setup code, the number of rows is 2. Then we build the program for the Mega 2560 platform using the appropriate libraries and compilers for the device. Again, we're not actually running on the device, but we're compiling as if we were going to send it to the device. So we are able to run automated tests of a program that uses standard library.